Welcome and good afternoon to our guests, students, faculty, alumni, colleagues, and friends. Thank you all for joining us at the School of Architecture and Design of the New York Tech. My name is Giovanni Santamaria, and I'm an associate professor and chair of the School of Architecture and Design at New York Tech. On behalf of Dean Maria Perbellini and the Lecture and Events Committees, I would like to welcome all of you to our lecture and event series for the summer 2021. New York Institute of Technology School of Architecture and Design is participating through multiple venues to the 17th International Architecture Exhibition, Venice Biennale 2021. Some of the work from our students is in fact exhibited in the Italian pavilion titled Resilient Community, curated by Alessandro Melis, in the section Architecture as Caregiver, curated by our Dean Maria Perbellini. Today's event is also part of the virtual Italian pavilion curated by Tom Kovac and Alessandro Melis. The theme of the lecture series that started in the spring 2021 and kept going during the summer is correlational crisis. 2020 marked a critical year in which environmental, health, economic, and social crises had become correlated, bringing forward the emergence of unforeseen global issues to be addressed with urgency. The spring and summer 2021 lectures and event series at the School of Architecture and Design at New York Institute of Technology creates opportunities to discuss how architecture, design, and urbanism can disclose implicit parameters and activate structural transformation in our ecological, social, and built environments. From how reality is measured and validated to automation and computational thinking, the series aims to question possibilities for disciplinary actions. The titles of today's lecture is Artificial Intelligence, Urbanism, Ethics, and Design. Our next event on July 6th will be titled Design plus Health, the Open City Paradigm, part of the Italian Pavilion Resilient Community in Spazio Peccioli. The panel organized between the SoAD and NYIT and the University of Genoa, titled Archipelagos of Changing Habitats, will follow on July 15. And more events will still be part of the virtual 17th Biennale of Architecture are scheduled in the month of August as well. But now it's my pleasure to introduce our moderators and to thank our moderators for all their effort and the great work they put together in organizing this event. Pablo Lorenzo-Eiroa, Associate Professor and Director of our MS program in Architecture, Computational Technology at the School of Architecture and Design at NYIT, and Tom Verebes, Professor in our graduate and undergraduate programs in the School of Architecture and Design at NYIT as well. Thank you so much, and thank you to all our guests. Pablo, Tom, the stage is yours.
Thank you, Chair Giovanni Santamaria. Thank you for all the work in the school. It's a great pleasure to host this event at our School of Architecture and Design in conjunction with the virtual Italian pavilion curated by Kovac and Melis. My name is Pablo Lorenzo-Eiroa, and I'm the chair of the Lectures and Events Committee. Today, as Giovanni just mentioned, we're going to discuss artificial intelligence in relationship to design and ethics, addressing them in relationship to the current correlational crises that are affecting our planet and our society at large, aiming at depicting the socio-political and economic dependent aspects that inform design, and that we should address them working through artificial intelligence, from the politics of design to ethical problems accentuating by it, or issues that may be addressed through AI. Our first is one of a series of events based on design and creativity through AI. This is the first part. And the second event will be on August 28th, and will focus on AI and ethics specifically in relationship to social issues and data trafficking, for instance. And that event is going to be co-hosted with Tongji University Digital Futures Director Neil Leach, and is co-organized also from NYIT by Tom Verebes and myself. As an introduction to today's event, we're going to be addressing in this one and in the upcoming event, the relationship between architecture as a cultural-based discipline in relationship to the role of emerging technologies through artificial intelligence. While architecture as a cultural project aims to displace the determination of cultural conventions, technological determinism through disruption can lead to the homogenization of media, and a series of questions about computation and design. Where does architectural creativity resides through the applications of AI in today's design environment? That's one of the fundamental questions we're going to try to address today. For an architecture of information, automating artificial intelligence for design opens architecture limited to the design of buildings to the design of systems which generate buildings, activating an interesting meta-architectural problem. The architecture of architectures is being parallel to algorithms that optimize algorithms or meta-algorithms. So we're also going to try to relate automation in architecture to automation in computation. As a brief genealogy of AI, perhaps to frame this event and the upcoming one can note the work of Claude Shannon in information theory and automata, Norbert Wiener, founding of cybernetics, including CA, cellular automation, simulation, exploring self-replication, and issues of automata. And the work of understanding intelligence through feedback, such as the success of increasing information flow in relationship to neural connections, but become reinforced through, or neural connections that become broken in relationship to the work in terms of computation automation, memory, and other issues, which was later expanded by Marvin Minsky in 1960 in relationship to cognition, linguistics, robotics, and automation, which became the work base for artificial neural networks in computation, basically in the founding of the artificial intelligence lab at the MIT. For a couple of decades, maybe in the 80s and 90s, there was an impasse in artificial intelligence, discussing machine learnings and other aspects with relative success and harsh criticism, until around 2010, big data started advancing the functionality of neural nets and confirming their relative success in relationship to the amount of data being filtered through neural nets and the activation of predictive data science, logged mainly through our cell phones, and data retrieval, but also problematically activating the issues that we're discussing nowadays, which is information trafficking by the big tech, right? But the reality is that enable the success of neural nets and their functionality in relationship to data retrieval. One of the issues that we're going to be discussing is the difference between supervised machine learning and non-supervised machine learning. Supervised machine learning problematically activates tag categories such as image repositories, for instance, ImageNet, in which tagging is structuring a certain type of reality by collecting and problematically projecting cultural biases in terms of the functionalism of how these data repositories are being implemented and used. This type of technologies now should be crossed with a certain cultural deconstruction of such biases in reality and how that reality is being structured and how it can be deconstructed in terms of how technologies are actually enhancing a certain kind of top-down reinforcing of certain biases in that.
Yo, machine learning is evil. They're getting rid of all the illegal immigrants.
Yes, thank you.
I can't hire Mexicans to mow my lawn anymore.
Yes. Well, we can open up the discussion later on, and actually I don't mind interruptions, but we can address that later on. But there are certain aspects, and that's why I'm being critical about machine learning. So thank you for the note. Here we are actually to address artificial intelligence from a critical point of view and from a cultural point of view. We also have the problem of non-supervised machine learning, which is dependent on pattern recognition and the flow of information rows, which depends on millions of data entry points, reinforcing at the same time certain conventions in our society, which depend on that retrieval. So there is a back and forth between one and the other. Machine learning is based on training the repositories.
Yo, what's your opinion on the machine learning that's being used?
Sorry, I have to mute you.
No, what's your opinion on the Israel and Palestine machine learning conflict?
Yeah, we are about to have a public discussion. We can address that in the questions. I keep muting, but this person keeps unmuting itself, but we can address that later. So continuing with introduction, we're also going to address generative adversarial networks, articulating neural nets and data flow, and feature recognition in terms on the contrast between two types of computation, which is data science in terms of data flow, and symbolic computation in terms of weighting different types of means of activating perhaps a more classical sense of computation through symbolic computation. Usually architecture, we tend to discuss ethics such as the type of interruption that we just had in relationship to social and environmental concerns, which we are addressing, of course. But there is less discussion in terms of what's happening with the ethics of design, what's being implemented and what data is being implemented and what data is left behind. So for instance, we have the
did
case,
you know Israelis are throwing bricks at Palestinians?
We have the case of Joy Boulamdemi research that addressed the fact that African Americans are less represented in data sets, and therefore that presents a big type of data biases when addressing design, for instance, mostly in terms of face recognition. Technologies, AI developers, software developers project their own sense of reality into the discipline, and new technologies disrupt by replacing architectural culture by providing new lenses of addressing reality. So one of the questions that we're going to try to address today is
what's your opinion? What is
the
why are you trying to silence me, I have freedom of speech. What is your opinion on?
Yes, can we do something about it? Because otherwise,
sorry,
we cannot have
Pablo. Yeah, he signed on in a number of different faces, and every time he speaks, I'm trying to remove him, but he keeps coming back on. So
all right,
I'm doing that.
Yes. So the issues, if we have the the possibility of discussing them, and we can continue with the event, are also based on the type of cultural biases that technologies projects into new technologies, and equally problematic, the issue of creativity and originality. How can we address the notion of design? But the notion of design is also shifting in relationship to new technologies and data science, because we cannot address design any longer as a personal self-expression, but we need to address design in different terms, since we are in a different type of reality, which requires a new epistemology in terms of the notion of design. And with that, I think that we need to address different aspects, different issues that still need to be addressed in relationship to design, and in parallel to social, economic, and political issues, such as the one that this person is raising up. But we can later on discuss that more in particular when we have the open forum and questions from the audience. Now I'm going to let my colleague and Professor Tom Verebes continue with today's introduction, and we will later going to introduce each of the speakers of today's event.
Thank you very much, Pablo, for your introduction. Thank you also to Dean Perbellini for her leadership and support, to Chair Giovanni Santamaria, and to Tom Kovac and Alessandra Mellis for including this event amongst the series of New York Tech events in the summer and fall of 2021 to be part of the virtual Italian Pavilion at the Venice Biennale. We've invited a wonderful panel of designers and thinkers to join us for today's event, to present work at the frontiers of the discipline, interrogating design creativity through AI. Thank you all for joining us for today. Expanding on the question, or rather maybe the provocation of design creativity through AI, a preliminary question to ask might be, why are we so obsessed with creativity? Given the legitimacy of our ongoing commitment to assuming creativity as a requirement for good design, how specifically can computational intelligence be actualized? Can computers attain the capacity for self-reflection, or consciousness, as we call it, to be understood in human terms as creative? Is creativity only possible by humans? Can computers dissent or misbehave, or even recognize the boundaries of propriety? Can computers, or rather the algorithms charged with potential to be trained or to learn, be coded with the capacity to conceive as yet undreamt of possibilities of world making? Where is the position of the human, or let's call simply the human the designer, in a world which is becoming post-human, in the sense of design agency being shared between the human designer and, for lack of better terms, the machine designer? Given the disruption of the traditional role of the designer in well-established modes of architectural production, where does the architect find herself, and what is her role amidst this displacement? Our discipline now, or yet again, has the potential to extend design intelligence, which has been traditionally the protected domain of the individual designer, or the domain of the architectural office whose identity is team-based, yet is still the product of a hierarchical organizational model, or the design intelligence of the collaborative in which authorship is argued to be truly shared. In tendencies, styles, and movements within design, information knowledge is organized as shared forms of cultural intelligence. In this light, when does the use of a new media, in this case, all the different kinds of media called AI, become part of the collective intelligence of our discipline to become the domain of shared culture? The past half century of postmodernity has largely been about the relinquishing of authorship. Agency in design applications of AI becomes shared between the human and non-human, or machine. As AI gains currency in architecture and urbanism and other design fields and art practices, the question of who is the author or designer takes primacy. Is authorship credited to the code writer or the algorithm? Is as the training of a data set to achieve specific goals, which has biases built into reaction? Is this where design lies? Interpretation and selection of outcomes is also a mode of discriminating and bringing hierarchy to the design outcomes of AI or any process. Creative agency is evident in the formulation of rules, in creating search spaces rather than solutions as acts of human creation. Questions then arise about the authority of decision-making in coding, interpretation, and design application. In this new technological milieu, does the designer become a curator, a choreographer, a conceptual artist, if we assume we cannot compete with the sophistication of the machine? Is AI limited to recombination through sampling of syntactic elements? When, how, and in which ways can an algorithm grasp the symbolic value of visual and spatial elements and images and the social meaning of architectural spaces? Intelligence of our civilization is not attributed to one single mind or human, but rather intelligence of our species and our civilization is collectively shared. This points towards a form of crowd intelligence rather than the modernist paradigm perpetuated in design of the single designer as a genius creator. And this paradigm of shifting from that single human mind as genius towards a shared or collective intelligence is quickly becoming a guiding paradigm of our day. In this light, the use of big data and AI as a form of crowd intelligence, replacing design inspiration of the individual designer, is gaining currency. In the current transitions in industrial paradigm, the first stage of information revolution was the digitization of the architect's practice initiated in the 1990s, but foregrounded for decades beforehand. Experimentation with creative tools at the frontiers of practice, research, and education had accelerated through the misappropriation of new technologies and media from other disciplines. For example, the film and animation industries in the 90s, gaming software, other media of extended reality, etc. AI continues the disciplinary tradition to appropriate new media, tools, and techniques from other creative computational disciplines, film, animation, simulation, computer science, etc. And as we charge forward in pursuit of innovation and our obsessions with the revolution of the new, AI holds the promise of inventing new, unforeseen solutions to problems otherwise easily solved through convention and habit. At this time, I'd like to briefly introduce our four speakers and presenters before Pablo will introduce our first speaker in greater depth. We have with us today four speakers and presenters: Alicia Imperiale, critic at the School of Architecture at Yale University and a visiting faculty at Pratt Institute; Jose Pinto Duarte, who is director of the Stuckman Center for Design Computing at Penn State University; Sandra Manninger, co-director of AR2 Lab, Architecture and Artificial Intelligence Lab at Taubman College, University of Michigan, and also together with partner Matías del Campo, co-directors in the design practice SPAN. Lastly, but not least, Roberto Batanzi, Program Director of the Masters of Urban Design program in the B-Pro at the Bartlett University College London, UCL. Thank you very much for being here. I'll pass it back to you, Pablo.
Thank you, Tom. I'm going to now introduce our first speaker of this event today, Alicia Imperiale. Alicia is a visiting associate professor of history and theory at Pratt Institute and a critic at Yale University School of Architecture. She was a Cornell University Society for the Humanities Fellow in 2016 and has taught at Università degli Studi Roma III, Studi Urbanistici, Columbia University, Temple University, and Parsons Schools of Design. Her scholarly work focuses on the impact of technology on art, architecture, representation, and fabrication in post-war Italian art and architecture and contemporary architecture. She is the author of New Flatness, Surface Tension in Digital Architecture, Seminal Space, Getting Under the Digital Skin in Re-Skin, Stupid Little Automata in Architecture and Culture, and Intellectual Geometric Character, Luigi Moretti and the Prehistory of Parametric Architecture in Log Observations on Architecture and Contemporary City. Her book projects underway include Alternate Organics, the Aesthetic of Experimentation in Art, Technology, and Architecture, and Post-War Italy and Machine Consequences. As a lecture, she gave us a brief of what she's going to present, and I'm going to just take you through it. And her recent publication, Raised After Technology, Abolitionist Tools for the New Gene Code, Ruha Benjamin looks at the relationship between machine bias and systemic racism and continues the discussion in an edited collection in Captivating Technology, Race, Carceral Techno-Science, and Liberatory Imagination in Everyday Life, in which she examines the interplay of surveillance and innovation and containment. Facial recognition, artificial intelligence engines are used to globally, ostensibly to surveil for terrorist threats, human trafficking, street safety, and the like, but are also the engine for racial profiling and discrimination, such as the alleged use in China profiling Uyghur Muslims on the basis of racial types. Alicia's lecture will also discuss other items. So welcome, Alicia, and thank you for joining us. You're muted. Yeah.
Okay. Yes, thanks. Thanks, Pablo. Thanks, Tom. Thanks. Ooh. Okay, now you can hear me. Sorry. Okay, so thank you. I thanked everybody, and thank you again for having me. I'm going to jump right in as I want to leave a lot of space for other people's presentations. Okay, so I'm going to share screen. Okay, everyone can hear me well enough? Okay, so Pablo, thank you again for all of you for inviting me. I'm wondering if it's an uncanny use of my initials, AI, that I begin the discussion tonight, but I'm not going to take that on just to own that. But I've often thought of that, so perhaps it's why I actually write a lot about computation. So. So I'm not going to read, so I'm trying to think of, this is almost a sketch. I'm going to kind of think about some of this idea of AI as having the potential to be a liberatory practice. Just sketching out briefly, I'm going to talk about three thinkers, contemporary thinkers. I'm going to look at four people in the 1960s, who I believe give us a framework, and just end with some thoughts in artistic practices. So it's very much a sketch, and I'm trained as an architect and as an artist, but I find that my mode of expression often comes through writing. Okay, so excuse me. Yeah, so I'm not going to repeat too much, but like thinking of recent scholarship Ruha Benjamin, professor at Princeton. So this idea of, her title is Wonderful Race After Technology, the kind of the layered meanings in that. But she looks at the relationship between machine bias and systemic racism. So I think even throwing in the titles, engineered inequity, default discrimination, coded exposure, gives us a lot of things to think about. So my talk is going to be more maybe thinking through the idea of creativity and aesthetics and giving us some frameworks that we can discuss after everybody's presentations. She continues the discussion in her edited collection, Captivating Technology, an edited series of essays. And she looks at the interplay of surveillance, innovation, and containment. So facial recognition apps and artificial intelligence engines are used globally. So I'm not going to repeat, Pablo just read was based on my abstract, but really like thinking that this kind of idea of profiling initially for ideas of safety can also be used in very dark ways. So, so I'm getting my technology here. Another author, Wendy Hoi-Kong Chun, writes about digital media and software studies and the intersection with critical race studies. In one of her first published works, she edited with Thomas Keenan at the New School, Old Media, New Media, a history and theory reader, she wrote in 2008. One of her key points that was the phrase that, quote, new media, which held currency in the early 2000s when I started writing about computation, late 90s, was a misnomer in that the emerging area of study really started in the early 1990s. She continued in her first book, Control. Sorry, I'm having some issues with my tablet where I'm reading from. She continued in her first book, Control and Freedom, Power and Paranoia, in the Age of Fiber Optics in 2006. So she's a pretty early writer. She looked at the flip side of the internet. Rather than an empowering technology of freedom, she argues that freedom became inextricable from control, and in doing so grossly undermines the democratic potential of the internet. So she continues to publish, and her work is interesting, as it is also highly technical. She's trained in English, but also as a systems design engineer. Her work that applies the most to today's topic, perhaps, of AI, urbanism, ethics, and design, looks at, and she's looking at her forthcoming book that's coming out this November through MIT Press, Discriminating Data, Correlation, Neighborhoods, and the New Politics of Recognition. She points out that, as does Benjamin, that facial recognition technology is based on the method of correlation that Pablo had mentioned earlier, which, as she describes big data's predictive potential, almost based on an idea of eugenics, like to breed a better future. It's also highly predictable and defaults easily to the sameness, right? Kind of an evening that in past work I've written about kind of genetic algorithms. There's a work through entropy where things kind of start to slow down and one would have to introduce novel change. So, it's the problem with the facial recognition is largely based on Caucasian or white faces. I heard Chun lecture a few years ago on this material at Yale, and it was striking when looking at the diversity of faces in our cities that if that's the default. So she argues for moving away from what she calls the, quote, vice-like grip of discriminatory data, and calls for alternative algorithms, defaults in interdisciplinary coalitions in order to desegregate networks and foster a more democratic big data. And I felt that this was relating very much to the topic of today. So, taking a different yet equally compelling critical approach to AI, which when we were chatting before our session, Tom is about to finish and everybody's kind of working their way through this book. So, as both said before, Kate Crawford will be invited to lecture later on this summer. So in her book, The Atlas of AI, Power, Politics, and the Planetary Costs of Artificial Intelligence, she also probes the question of AI, artificial intelligence as not being either artificial or particularly intelligent. Her book is a critical history of the data on which machine learning systems are trained. So in keeping with contemporary interest in architecture and extraction systems, she points out, so I think there's a relation to what we're working on in our field. She points out that AI is a technology of extraction from the minerals that are extracted from the earth to low-wage laborers across the planet, and actually to the source material of the data that is extracted and provided for by countless users. I think that's a really interesting point of her work. She also trains her mind on undemocratic governance and increased inequality. Unlike Chun, Crawford doesn't discuss the technical details of AI, but takes on like a material and political perspective on what it is needed, what's needed to make AI and how it centralizes power. So I'm just trying to quickly raise these various thinkers that I've been looking at over the past few years as giving us a kind of lexicon of terms that we can use to flesh out the profound ethical issues that undergird AI in our conversation today. I too, while trained as an artist and an architect, find that my primary outlet, as I said before, is for creativity is writing. So I'm excited to hear the other speakers and colleagues discuss their work in relation to ideas of design and ethics and how the very creative act can be highly ethical. If we look at recent work in automating AI for design, it does, as the organizers of today's event state, that architecture that it need not be limited to the design of a building itself, but in the design of a system that can generate buildings and as such activating a meta-narrative. Excuse me. So as a historian of computation and science and technology studies, I have focused my work over the past maybe 15 years, almost 20, on the late 1950s and into the early 1970s. When I hear the term meta-architecture or of systems generating architecture, I think of Christopher Alexander's 1968 essay, Systems Generating Systems. I wasn't able, I'm traveling, so I wasn't able to kind of pull everything, but it's a really amazing article that was in architectural design in '68. So he's kind of basing some of this on Noam Chomsky's generative grammar. So essentially, if a generative grammar, he thinks, could produce all variants of sentences and meanings, Alexander said that a generative system could also produce architecture. And there's a lot more to be said about that essay. It's quite an important essay. In my own work, I'm going to show this chapter that actually is an excerpt and an expansion out of my work on my dissertation. In this post-1965 Italy, the meta project, Yes and No, originally with a question mark, by Alessandro Mendini. It looks at theoretical housing projects and by artist Enzo Mari. So I'm just going to show this very quickly, based upon combinatorial thinking and calculation. Projects like this were common in the mid-1960s with a population boom in Europe that pushed issues of mass housing in cities and finding strategies to introduce user input and to reduce the horrible identical mass-produced housing that one was seeing. So I just will kind of go through the next two slides. I'm sorry if I keep losing my Zoom. Travel and Zoom meetings are a little bit difficult. So I just want to show this very briefly. If anyone would like access to a PDF, I'd be more than happy to provide it. So there was this idea with Mendini. It's very theoretical. So the images on the right side, and this is in Casabella in 1969, was like looking at language, at concrete poetry, at the iteration of Islamic tiling patterns, door and window schedules, and understanding, or very early computer art, and understanding this idea of the combinatorial of the adjacency. And it's also another work I've written on cellular automata. So in this work, I'll just go through it briefly. This other part of like looking at Enzo Mari and the artists and Bruno Morasutti were thinking about in the time, so I believe this project was 1965, it's pretty early. And they were really thinking through like how could one start to cycle through and have, you can see here on the left, they were thinking through a set of algorithms that would allow the housing units to be pushed back and start setting up relationships. Also, here's a kind of set of sections, building sections, here's the numerical code, and had a lot of affiliations with the rest of Enzo Mari's artwork. So to circle back after speaking about AI and ethics and creativity, I really don't, and I'm not in the capacity to discuss exactly how AI contributes directly to the making of architecture. We've got 3 other like amazing speakers today who are going to speak to that, and also to our hosts who are very, very active in this area. But architecture and the city. So there's a thought, I think, for a future piece that I'm not really covering today. So how can the city become, the architecture and the city itself are the surfaces upon which the cameras are mounted and are kind of recording our every movement. So I'm like wondering in one sense what the city and how architecture writ large in combination becomes urbanism and how that becomes kind of this scaffold. So I also, so looking, oh my goodness, I'm so sorry. It's not letting me click through very easily. So I wanted also just to reflect back on Yona Friedman in the idea of his ville spatiale. So how can we learn from the experiments of over 50 years ago that we're directly engaging combinatorial thinking, a kind of proto-computation or a nascent idea of artificial intelligence? What systems were set in place? How were the projects at the time deeply politically engaged? How can we be inspired by someone like Yona Friedman in his 1967 project, I'll show in the next slide, the flat writer? He imagined an input device where one could design one's own project within the superstructures, like his ville spatiale, which he had worked on from the late 1950s. And the project in flat writer was an idea that one could, he asked each future user to design what their ideal apartment would be, but then the computer would negotiate with the other units to find a way to mediate individual desire with the larger community's needs. So these technologies are also used by artists and architects by understanding the political and social valence of the ludic. Play, as Roger Caillois describes in his Man Playing Games in the 1960s as well, sets up situations that push against the norms of social play and open new avenues of potential social liberation, participation and liberation. And just kind of coming to the end here, in a current, Lilo Curto and Bill Elcott, who I wrote about in my book of over 20 years ago, have a current exhibit online, computationalcreativity.net. So I thought that kind of the confluence of the idea of creativity and AI for the ICCC 21, featuring a number of interesting artists who are pushing back on big data and in a sense investigating in their own work some of the themes that the writers I was just speaking about are looking at, but using AI in their art practices. The artists provided, and when you click to this page, provide links to their own websites, but while the work varies dramatically, the projects are visually stunning. And as the creators write, each raises questions about the very nature of art, its relationship to technology, and the role this type of creativity will have in future societies. I'll just show very quickly a couple of projects. Derek Curry and Jennifer Gradecki, kind of one of their projects from 2020, Infodemic, using neural network generated video. That's an amalgam of celebrities, personalities, tech moguls who all spoke misinformation about the coronavirus, and using conditional generative adversarial networks. They're used in some deepfake technologies. So kind of their own commentary on that. Second to last slide. On their crowdsourced intelligence agency allows users to experience how open source intelligence is processed by the intelligence agencies themselves. It has several parts: a surveillance interface where one can test one's own social media post if you're being flagged or triggering, a machine learning classifier where a user can assess the accuracy and idiosyncrasies, allowing users to choose how they want to navigate and kind of post in their own social media. So just a final thought. The work by Ellen Perlman is intriguing. So she's a recent PhD working kind of in new media. So she wrote an opera. It's called Noor, a brain opera. So it's the first fully interactive, immersive brainwave opera where a performer we see here wearing a wireless EEG brainwave headset touches, gazes, walks around, and I'm quoting Ellen's website, audience members in a 360-degree theater while a story is narrated. Her measured emotional states trigger video, sound, and a pre-recorded libretto as her emotions are displayed as lifetime colored bubbles. The opera rhetorically asks, quote, is there a place in human consciences where surveillance cannot go? And I think that is a fitting question to now see the work of the other speakers and to continue our conversation. Thanks very much.
Thank you very much, Alicia, for your insightful presentation on the substantiation and historical theoretical background and contemporary practices of the use of AI in design, ethics, and creativity. Our second speaker, Jose Pinto Duarte, studied architecture in Lisbon and then completed his MArch and PhD at MIT, and is currently the Stuckman Chair in Design Innovation and Director of the Stuckman Center for Design Computing at Penn State, whereas he is Professor of Architecture and Landscape Architecture and Affiliate Professor of Architectural Engineering and Engineering Design. Prior to joining Penn State, Pinto Duarte was Dean of the Lisbon School of Architecture and President of ECAD, the European Association of Computer-Aided Architectural Design. He was co-founder of the Penn State Additive Construction Laboratory, the ADCON Lab, and his research interests are in the use of computation to support context-sensitive design at different scales. Recently, he co-edited together with Branko Kolarevich the book Mass Customization and Design Democracy, published by Routledge in 2019. And his team was awarded second place in the finals of the NASA 3D Printed Mars Habitat Challenge. In his lecture, Jose will describe that while AI tends to be equated with machine learning today, it includes several other techniques such as shape recognition, rule-based systems, and optimization. These various techniques are complementary and can be articulated to form comprehensive approaches to architectural and urban design. The objective is to support case-sensitive design at different scales, understood as an optimized response to unique design contexts, leading to maximized building performance and maximized resource consumption. An important application of this approach is the provision of mass customized housing and urban environments in a world scenario of rapid urbanization and population growth. Welcome, Jose Pinto Duarte.
Thank you, Tom, for introductions. Thank you, Pablo, also for the invitation. It's my pleasure to participate in this discussion. Let me share my screen to show you my presentation. Can you see the slides?
Yes.
Okay. So as Tom said, my presentation is about the using of AI to support context-sensitive design. So although we equate today artificial intelligence with machine learning, artificial intelligence can be defined as a study of the computations that make it possible to perceive, reason, and act, to use a definition by Patrick Vincent in his book, Artificial Intelligence. I also would like to point out that we can use the Turing test to verify whether a machine is capable of intelligent behavior. And I'll refer back to these two issues later in my presentation. So as Tom was saying, AI paradigms are not just, constricted to machine learning. There are many other paradigms like semantic nets, search and optimization, rule-based systems, frames, constraint propagation, and so on. I've used some of these on my own work, as I will show, but it's important to note that we are not limited to machine learning. So the center that I direct as a mission to contribute for the achievement of United Nations Sustainable Development Goals, such that we support integration of digital technologies, including AI, in the design and construction. But I should also say that the focus is not on technology, but on strategically deploying technology to address contemporary societal issues. So again, the goal is actually, design problems, to solve design problems. So I usually like to start my presentations with this slide because it's my motivation. So it shows the growth of human population. And we have achieved such a state that we will need to build over the next 20 years as many houses as you have built in the past 2,000 years. And therefore, we need new approaches to design. So people lack affordable housing. When they cannot buy a house on the market, what do? they basically build their own houses. So we have what we call informal settlements, called favelas in Brazil or slums in the US. But this in type of environments can be seen everywhere in the world. The usual governmental approach on the other extreme relies on mass production, prefabrication, and leads to very uniform environments. And what we have as a reference is these historical settlements that have features that we value. So the goal of my work is to develop approaches to design that will allow us to design environments that have the qualities, but not the flaws of informal settlements, and are very close to these historical settlements. So this is a fact. According to the United Nations, 900 million people lived in informal settlements in 2018, and it estimates that this number will double by 2025. It's a huge scale, a problem with a huge scale. So my standpoint is that informal settlements are not the problem, but the solution with problems. So they have qualities that we value, including being especially very rich, but they have many flaws. They lack basic infrastructure. They have no public spaces and have a huge ecological footprint. So my hypothesis is that we can use digital technology and AI to provide the means for developing and applying methods that are inspired in the example of informal settlement. So what I'm looking for is a new method of planning and design low-income urban areas. Just, to put this into context with an example from science, we have the DNA code, which is the code of life, which, it's manipulated by nature to generate different creatures in a way that are adapted to the environments where they live. So this is basically the idea that I want to bring into architecture. That's what I call context-sensitive design. So we have the code of architecture that we manipulate to generate buildings that are adapted to the context, the social context, the physical context, and so on. So this goes back to Herbert Simon's idea of the sciences of the artificial, where he postulated that, as the goal of natural science is to uncover the laws that govern natural systems, we should develop artificial sciences with the goal of uncovering the laws underlying, systems that are man-made. So basically, it's talking about the use of algorithms in design. So an algorithm, as you know, is a set of instructions to do something. In this case, algorithms for architecture. Well, it turns out that the idea is not new, because if you look back into the history of architecture, we see in books like The Disease of Architecture by Vitruvius, Alberti, and others, that's exactly what they try to do. They try to develop algorithms to design buildings. And in fact, they did it with such a level of detail that is very much straightforward to turn their writings into computer programs that have the ability to generate 3D models of buildings. Like in this example by one of my students, where he turned the chapter on how to design theaters into a computer program that asks you for how many spectators, and will generate a 3D model of a theater for that number of spectators. And then once you have the digital model, we can actually use digital fabrication to make the physical model. So this is the idea, basically solve the housing problem by developing systems to generate buildings, and then using geofabrication to very quickly and inexpensively materialize these systems. So this is the conceptual framework. So we have a design system that reads the context and generates a solution, and then we have a production system. They both rely on computers, taking advantage of the high processing power of computers to very quickly generate a solution or to make that solution. So if you look deeper into the design system, we see several other subsystems, like a generative system to generate alternative solutions. And then we need an evaluation system to rate and rank the solutions. And therefore, we also need a search system to find, let's call it for now, the optimal solution, the solution that best fits the current context. So this is what I did, several years ago for my PhD thesis, using as a case study the work of Alvaro Siza, a Pritzker Prize-winning architect. So basically, I studied his work. I extract the rules that he used in the design of houses. and we can manipulate those rules to design different houses. So the idea is that we customize the houses. In other words, you manipulate the system to generate a customized house, so basically using his rules. So that was implemented in a computer program that has the ability to generate a customized solution. It works like a digital architect. It reviews the client types in information, and it will automatically generate the 3D solution. So the Turing test in my case was done with Alvaro Siza. So I put several houses in front of Siza, some houses that he had designed and houses that had been output by the system. And he was not able to distinguish the house output by the system from his own houses, from his own designs. So as turns out, and he asked me at the time, so who's the author of this house? Is it me who developed the system in the first place? Is it you who actually codified this into a system? Or is it your student who used the system to generate a new house? So there are very interesting issues, authorship issues that are raised by the use of these technologies. My opinion is, as long as you are doing something that is meaningful, and solving the housing problem of many people is actually a meaningful, endeavor, I don't care. Authorship for me in this case is secondary. So once we have the system with the ability to generate alternative solutions, we can actually constrain the derivation of solutions towards cases that achieve specific goals, like minimizing energy consumption or maximizing thermal comfort and so on. So we can customize a house, we can generate a very diverse urban environment by following this approach. So then we are left with the problem of how to materialize these solutions. So we rely on digital fabrication systems. There are basically two paradigms. One we could call the kit of parts, standard components, like I like to say it's like the Lego system. Standard components, you combine them differently to generate different solutions. Or you can actually use additive construction. So more recently, I became interested in digital additive construction and using digital additive fabrication because of some of the advantages, including the speed of construction and the potential for lowering the costs. So I've recently applied this paradigm, both the digital design paradigm and the digital fabrication paradigm, to enter the NASA competition with the Penn State team. So we have two completely different environments, Mars on one hand and Earth on the other. And we were asked to design houses for both environments. The house for Earth should be built. So what we did, we developed a platform using the same components I mentioned before that use a parametric design system to generate candidate solutions. We use performance analysis software like structural performance or environmental performance or constructability performance to rate and rank the solution. And then we use optimization to find the best solution. Best in this case means a solution that can provide an answer to the problem that's the most adequate given the current scenario. But at the same time, we had to actually simulate the construction to make sure, for instance, that the robots would not collide during printing. So this is an example of the BIM-based platform that we developed to generate candidate solutions. This is actually the use of environmental performance and structural performance software to check the performance of the generated solutions, and then we use optimization to find the optimal solution for different scenarios. So completely different scenarios, Earth and Mars, with different gravity, with a different atmospheric pressure, but the same platform, the same set of design rules. So the idea is that you put the solution into different environments and they will evolve differently. And then, so this is the outcome of running the system for two different scenarios, Mars on the left-hand side and Earth on the right-hand side. And then we have to simulate the construction. That's how we qualified for the finals to show that we could actually make, print the solutions. Just to speed up the video a little bit. So we had to show that we were able to print to qualify for the finals. This is actually, a video of the actual construction at the site. The use of the technology allows us to print for the first time a fully enclosed structure. So we printed everything: the foundation, the walls, and the roof, all together. So this is an example of the use of this kind of technology. I'm going to very briefly show 2 other examples. So one is, trying to find out the impact of urban form on COVID-19 propagation in the American cities. So if you look at 2 different places, let's say New York and Los Angeles, that have a totally different urban forms, we want to study the impact of urban form on the rate of the disease propagation. So you basically identified a set of features describing urban form and a set of features describing, disease propagation, and try to find correlation between the 2 using machine learning. So that's a study that's still being evolved, looking at different American cities with different scales, medium size, big size and small size cities. And that's the first results that we are obtaining by running the machine learning algorithm to identify the impact of different features like, walk score or population density, population size, and so on. So the other example, we also use machine learning. In this case, to find correlation between urban form and energy balance. We want to find out what's the impact of urban form on the production of energy and on the consumption of energy in community microgrids. So microgrid is is defined as a community that can, produce the energy that they need to operate. So we use San Diego as a case study. We have identified different urban features to describe urban form and to find a correlation between, urban features and certain data for energy consumption and production. Using artificial neural networks to find that correlation. And this is a graph that summarizes the output. So we were able to identify which features actually have an impact, might have a positive or a negative impact on energy balance, on energy consumption, and energy production. So 3 different examples of this AI, artificial intelligence, different paradigms for designing, raising some interesting ethical issues. So this is my contribution for the discussion. I'm looking forward to our discussion. Thank you very much.
Thank you very much, Jose. It's a great presentation and I actually enjoyed it a lot. So thank you so much for the precision of thinking and to address all the issues, and congratulations for the great work that you have been doing for so many years. Our next speaker is Sandra Manninger. Sandra Manninger is an architect, researcher, and educator. Born and educated in Austria, she co-founded Span Architecture together with Matías del Campo in 2003. Span Architecture's research highlights how to go beyond beautiful data to discover something that could be defined voluptuous data. This coagulation of numbers, algorithms, procedures, and programs uses the forces of thriving nature, and passing through the calculation of multi-core processors knits them with human desire. Sandra Manninger has taught internationally, and her award-winning projects have been published and exhibited, for instance, at the Venice Biennale 2021, at the MAC, many Venice Biennales actually, the MAC Autodesk Pier 1, and has been included in the permanent collections of the Frank Centre Val-de-Loire, the Design Museum Die Neue Sammlung in Munich, or the Albertina in Vienna. Her lecture will address the rise of artificial intelligence and machine learning in recent years has posed a challenge to the architecture community. How will this new novel technology shape the way we conceptualize, design, fabricate, construct, and maintain our environment? This talk interrogates the rise of machine learning through the lenses of practice and education. Thank you, Sandra, for joining us.
Thank you so much. Can you hear me?
Yes.
Okay. So hello, everyone. My name is Sandra Manninger. Together with Matías del Campo, I run the architecture practice SPAN, and I'm co-founder of the RLab we will see what name we will come up with at the end. So the Laboratory for Architecture and Artificial Intelligence at Tubman College, which runs in collaboration with Michigan Robotics and Computer Science Michigan. So let me just. So I'm not one who is being easily traced on social media. So before I start, I should probably mention that my interest in the implementation of computational tools has always focused on developing design protocols that are providing a body for the algorithmic procedures to manifest in order to extend our creative potentials and to be able to represent scientific and mathematical concepts of space. My own history in exploring AI and machine learning started in Vienna. Vienna is home of the world's oldest cluster of research in artificial intelligence, the OFI, the Austrian Institute of Artificial Intelligence, an offspring of die Österreichische Studiengesellschaft für Kybernetik, a registered scientific society founded in 1969. About 30 years later, around 1994, I met Dr. Arthur Flexer, who you see here on top left, who was then a student at the OFI and who first introduced me to the concepts of neural networks, his field of research. A couple of years later, in 2006, our office SPAN conducted the first machine learning workshop in architecture at the Angewandte in Vienna in collaboration with the OFI. And in 2011, I was invited to give a talk at their institute. But after moving to the University of Michigan, a collaboration with Michigan Robotics and Computer Science paved the way for a series of new design techniques. In particular, the director of Michigan Robotics, Jesse Griesel, and PhD student Alexa Carlson have been pivotal to this collaboration.
Sandra, sorry to interrupt, but we don't see your presentation. It sounds like you were referring.
I'm sorry. I will go back.
I thought that you were doing a first introduction theory, but
There's one reference to your thinking, so I thought I should interrupt.
All right. All right. All right. Can you see my screen now?
yes. Yes.
Okay, thank you. So again, thank you for having me. I really enjoyed the two previous talks, and it's almost hard to start after these great introductions. But here you can see an example of Vienna, where I met Arthur Flexer. And I just wanted to give you a brief introduction about me because I'm so hard to being traced at social media. I'm not on Facebook, and so here you can see Arthur Flex on the left here, a good friend that I met in 1994, and he was pivotal in my introduction to neural networks and in design field. So before I start, I would like to thank the Lectures and Events Committee for the generous invitation to talk today to you about aspects of artificial intelligence, machine learning, and architecture design, and to present some of the projects and research that I've done in the past. Artificial intelligence is deeply embedded in our everyday life. Neural networks help diagnose medical cases, make decisions on bank loans, decide parole cases, read your bank checks, filter job applications, drive cars, fly drones, detect fraud, translate text online, and recommend to you which book to read next. They are part of our households in the form of quasi-intelligent thermostats and security systems, help finding our way in cars by using adaptive maps, and are close to the human body in the shape of smartphones and watches. They recognize your face and the way you type, and help you photograph like a pro, among other things. The data generated by all these activities aid in perfecting the training of all these algorithms. In other words, AI is everywhere. And this is only the examples that we currently perceive as humans. The massive underbelly of artificial neural networks providing intelligent service, managing copious amounts of data on servers, organizing the routes data takes, controlling traffic lights, managing shipping, subway schedules, and many other mundane tasks elude our field of vision. So how does this ecology influence the field of architecture? First, we must distinguish between generalized AI and applied AI. General AI is an AI that can perform in a variety of ways, fulfilling a series of different tasks. Think data or Star Trek, the next generation, or agents meets from the metrics. And that is obviously most of the time the part that is rightly so critically received and criticized. And then there's the field of applied AI that is focused on one specific problem. For example, driverless cars that need to recognize the difference between a car and its environment. For example, a tree, a pedestrian, and so on. And machine learning, or ML, is part of applied AI. And this is actually the field, the tool sets or models we currently use in design and construction of the built environment are located. So how does this technology change the way we conceive, conceptualize, create, design, fabricate, construct, as well as maintain our built environment? How does it change the role of the architect? And how does it change the way how and what we teach? It is most certainly researched for its capacity as a tool for expedience. This is an example from research of the Technical University Munich, coming from the fields of computer vision and so-called digital twins. This machine learning model is being trained to recognize parts of the construction site, like columns or scaffolding, parts that then will be connected to a BIM model to collect projected and actual construction progress. But ML model can also be used as a tool for surveillance, like this older example from a research project of the Hong Kong Polytechnic University from 2017, where the scientists observed individual workers' productivity. So I think this example clearly shows that we as architects have to engage in this conversation. Before we can start to look for possible scenarios, we need to get to know the individual constituent elements of this technology to be able to employ them in a way that, while using it for convenience, expedience, and service, also empower new forms of creativity and go beyond superficial forms of so-called ecological design. So what are these constituent elements? Machine learning relies on the acquisition of copious amounts of data, whereby the data can be of any form or shape. In supervised learning, this data is being labeled or tagged. So each of these sets or letters would be labeled as a 3, as a 8. For some, we would probably have problems to distinguish is this a 4 or a 7 that is actually being trained. And in unsupervised and reinforced learning, the model is trained to find hidden structures within the bulk of these data sets. So the second constituent is a mathematical model with its corresponding loss function, and in its simplest form, this model can be a line or curve. So in its simplest form, we see here a regression model with just a line, a linear regression model. But in most cases, it is a multidimensional surface or tensor that either needs to go as close as possible to all data points or separates them into classes. So machine learning is actually a geometrical problem. And although the mathematical models do have weights and they also have a so-called bias, the actual bias that is being discussed and criticized in the realm of ML is the bias that is generated through the acquisition of data sets. And that is exactly where we as designers and architects engage with ML. Rarely will we be choosing the specific mathematical model, at least not in the beginning, but we will be asked to collect, train, and if necessary, label the data sets the neural network will be tested on. So here's an example from 3 students, Hannah Doherty, Mariana Moreira de Carvalho, and Iman Suleiman, from the first thesis studio that I taught in AI that used image classification with a convolutional neural network that was coded in Python. So here they were defining target classes, and and train a model to recognize them using labeled example photos. So the collected data set consisted of approximately 1,000 images in each class. And the neural network then will be extracting features from each image. But how can we use this now as a designer? When you look on the image stack in the middle of the first corner column on the left, you can see a data set of images of 3D agglomerations in gray. So for many years, I have been developing a technique to very quickly create three-dimensional patterns and introduce this technique to my students in the design studio too. So that proved to be very useful now. ML models are mostly very data thirsty, and rarely can a student create enough material in a semester, nor do they have a backstock of design to feed the algorithms. But with this technique and working in teams, I could ask them to create an additional set of their own model images to be able to insert their own sensibilities and spice up their own work with ML models. Usually before we introduce these new techniques to our students, we go through our own research and apply a variety of models to different data sets. Here, a neural style transfer with pre-trained weights seemed to be quite successful for the generation of landscape and urban conditions. Again, combining it with my own or office's sensibilities. So here, this city does not exist. It is generated by an algorithm using pre-trained weights that have learned on the famous ImageNet dataset that contains over 14 million labeled images. We were using these images to train the neural net to recognize distances between infrastructural elements, population densities, scales of subdivision or block sizes, even building heights, to integrate them later into BIM software, for example, to calculate wind loads or potential flooding. Here we applied a 2D style transfer model to create a series of plans and sections, and we are actually in the process of creating a new form of data set for more intuitive creation of plans. But to be honest, since working with computational tools and techniques, we always use three-dimensional and generative modeling. Our work was inspired by the amazing architecture of Ray Cappy, Frank Lloyd Wright, John Lautner, other flows, or in other words, the round plan or space plan rather than stacked floor plans. If we wanted to integrate the quality of these architects and the ability of space into a neural network flow, we had to find different machine learning models and even more laborious create our own 3D data set. This was the first attempt, a neural renderer model developed at the University of Tokyo. It is taking a 3D mesh geometry and a style image, adds texture to, so creates a new mesh. It was not yet what we were looking for, but a reasonable next step in this research. And we also had a special project with a very special client. These are two of them. We had been collaborating with Michigan Robotics for a year on studio projects and paper presentations. They asked us to design a robot test ground for the multi and bipedal robots. The robot garden needs to have a series of different geological features to test the robots: sandy terrain, rocks, grass, earth, etc. We created a database with several thousand satellite images of various terrains to train a neural network to hallucinate these features on a given mesh model. In addition, we created several data sets of architectural features, such as fountains, columns, etc., and styles such as Gothic or Baroque. Playing with the weights, and we started to get a grip of how to use the technique until we got usable results. Making steps into the landscape was a requirement of the robotics lab, as well as the water feature, which will allow for flooding the robot garden to test the robots on slippery surfaces and in winter on ice. So here you can see the variety of models that we hallucinate to create features and some stills from the hallucination process. And an image from beautiful errors or glitches, that's the moment we are living for. But the first project we applied a neural render model was actually designed for the competition for the Austrian Pavilion for the Dubai Expo in 2020. It was our first successful AI-driven project. The ceiling of this project is a 2D to 3D style transfer acting between Baroque sensibilities as a style and a series of modern ceilings as the target. The result is a strangely articulated ceiling that oozes Baroque presence. The floor is intentionally kept modern to create a space full in tension between modern and Baroque sensibilities. The next work is based on a collaboration with Computer Science Michigan, who are using a powerful neural network architecture for machine learning on graphs. This was our first exploration to work directly on 3D meshes. The question was, can we collect 3D models from the hand of a designer, creating a large database of models in two distinct categories, houses and columns, in order to train a neural network to come up with additional model solutions that are generated using the learned features of the trained network. As said before, to create a design strategy that employs actual 3D geometry, we had to find the right model architecture, and we even more so generate a data set of 3D models. This is a screenshot of a geometry created for this data set containing around 1,500 labeled OBG mesh models of specific architectural classes, houses, and columns. It was the labor work of summer 2020. We refer to this data set as the sensibility data set. The next step is to train a graphic convolutional neural network on this data set to learn a mapping function between the Cartesian coordinate space of 3D models to our defined label space of sensibility features. And the next step is and the final step is to placing the trained graph convolutional neural network in an optimization framework that takes in a user-specified 3D model as input and then deforms the vertices of this model to optimize the shape of a user-specified style, aesthetics, or functionality label. So how can a neural network interrogate the inherent sensibility of a specific designer? So after our research, we can assume that we can model a designer's sensibility as a high dimensional function that can be learned from 3D models and applied to generate novel design solutions. The design technique, whose backbone is graph CNNs, is capable of modeling both the perception and creation of architectural objects. And you can read more about this project in the paper 3D Graph Convolutional Neural Networks, which we presented at Acadia in 2020. And lastly, to see how these pieces are implemented our workflow in the office, in spring 2020, we were invited to participate in the international competition for the new 24 high school project in Shenzhen, China. The competition was for a large-scale school for around 3,000 students and included, next to classrooms, an advanced technology fab lab, a public multi-purpose building, a library, laboratories, PA building, dormitories, as well as outdoor sports facilities. In the months leading to the competition, we had been experimenting with attention guns, attentional generative adversarial networks that allow converting text to images. The competition seemed like a perfect candidate to implement the research in a concrete project that had very specific requirements. The motivation to explore attention gun as a design technique in architecture can be found in the desires to interrogate an alternative design methodology that does not rely on images as a starting point for architecture design, but language. ATN GANs explore the information space present in programmatic needs expressed in written form and transform them into a visual output. This visual output can be further processed into three-dimensional models that transport lingual information into fully developed architectural entities. For the last 2 years, we have been trying to explore methods emerging from computer science that allow us to use neural networks in 3D. Instead of folding 3D into the two-dimensional plane of a 2D image and then unfolding them back again into 3D, thus losing information in the process, we wanted to create a workflow that works entirely in 3D. thus resisting the Albertian paradigm in creating an abstraction of reality via plans, sections, and other methods of architectural representation. The ATN GAN process is still not entirely 3D, but rather 2.5D. It was certainly fun exploring how a neural network would respond to a cue such the building is used for sports, is colorful, and has a crenellated crown, or the canary yellow building is a laboratory and is mocking the ground. However, this is not produced the final plans. This still needed quite some human intervention to work properly. So what does it mean if we are being assisted by tools that learn, when we move from using expert systems to learning systems, when we live with robots and machines, when we extend our senses through an added perception of the world? Can these tools extend our creative potentials, and will they aid us in representing scientific and mathematical concepts of space? Who will be the curator or advocate of data, the data we acquire and the data we produce? And who will be the participants in the design protocols that we are about to generate? These are the questions we discussed recently within the Neural Architecture Group. Matthias Del Campo and I started together with Daniel Bolojan and Emmanuel Ko. And we discussed these topics also at the RD Lab, the Laboratory for Architecture and Artificial Intelligence, a collaboration with Taubman College, Michigan Robotics, and Computer Science Michigan. And I also take the opportunity to shamelessly refer to Matthias Del Campo's upcoming publication, Neural Architecture with Oro, that should be available end of this year. And also I have to apologize, due to the brevity of this talk, I had to leave out a lot of technical details. If you want to know more about them, there's a series of lectures and tutorial videos on our YouTube channel. And that was it. Thank you very much.
Thank you so much, Sandra. Your work really truly lies at the frontiers of disciplinary research in machine learning techniques in architecture and urbanism. And I love the term that you use, the hallucinations of the consequences of train your neural networks in various scales and problematics of design. So thank you very much. The contribution is exceptional. Our fourth and final speaker today, Roberto Batanzi, is an architect, researcher, and educator who's based in London. He studied in Italy and Canada before moving to London. He's the director of the MArch Urban Design Program at the Bartlett UCL and RC14 Design Tutor. He's the author of Digital Architecture Beyond Computers, Fragments of the Cultural History of Computational Design, published by Bloomsbury in 2018, and editor of Walking Cities, London, published by Camberwell Press in 2017 and Routledge in 2020. Roberto's research analyzes the impact of digital technologies on architecture and urbanism, and he's presented and exhibited internationally. His presentation today takes the premise that despite the rapid and pervasive penetration of all aspects of society, the introduction of machine learning algorithms and spatial design has been met with relative little theoretical discussion. Rather than stressing the functional advantages that automated algorithms can bring to design, the challenge is to foreground the theoretical issues related to the introduction of machine learning methods in spatial design and contextualize them within the repertoire of disciplinary techniques developed by architects. Roberto's presentation will discuss some of these points through the work developed by Research Cluster 14 in the B-Pro program, Master of Architecture of Design, Urban Design, at the Bartlett at UCL. Thank you very much, Roberto.
Thank you very much, Tom, for the introduction and the invitation. And of course, thanks to Pablo as well for the invitation and also the opening remarks, which I think set a very rich scene for conversation. Hopefully, my presentation will pick up some of the points you raised and provide some sort of, let's say, point of view on them. I shall share my screen, and you should see something that says urbanism beyond cognition. Sorry.
Sandra, I think you need to stop sharing. Sandra, are you there? There you go. I just activated myself. Now we can see your presentation.
Perfect. So as I was saying, thank you very much for the invitation, and I'll go quickly through to the point in a way. So as Tom just mentioned, basically my time is divided between running the urban design master at the Bartlett and also working as a researcher and historian of digital technologies. And today's presentation, although in a sort of general manner, will address both points of this activity. Obviously, the work at RC14 is not something that I do by myself. Tassos Varoudis and Irini Tsoutknida are also teaching with me, and they've been doing so for a number of years. So also the other thing that I want to perhaps discuss more is, of course, that I tend to have a more urbanistic look at the issue. So rather than talking about architecture per se, I also want to talk about perhaps the larger scale that is impacted by the use of machine learning algorithms in design. So we have we pretty much, regardless of where we live, we have seen the emergence of buildings like this one, of the distribution centers of some sort. And these buildings are, of course, fully automated buildings. In fact, buildings in which let's say the computational space of design and the physical space totally collapse, as the building is basically a physical computer that operates at the scale of the city and also of its infrastructure. The interior of these buildings is also by now a known feature, as a known, let's say, environment in which objects are organized randomly, because of course algorithms and RFID tags, sorry, allows us to find anything in any position. And so they have a kind of form of organization which is a machinic one. It's not something that it mirrors any, let's say, human ways of organizing space. And one of the interesting things that comes out of this kind of organizations is that, of course, the more the functional aspects of organizing objects in space is taken care of by machine and done so with increasing precision and ability, more space opens up for investing this form of organizations with other kind of values, some of which were also introduced at the very beginning of this session. So in a way, we know that these kind of buildings are, as I said, basically physical computers, objects that are very closely mirroring the computational architecture that underpins them and translates it into a physical environment. Now, this point, I think, is quite interesting because for a number of reasons, which I will explain in a second, but definitely the ability to organize objects in space, in space-time, is a skill that architects have been mastering for centuries. And I think this is one, perhaps, of the valuable counterpoints that we can begin to take into account when we absorb techniques for organizing space that have emerged somewhere else, namely within the field of computer sciences. So even in a very kind of rough overview of the history of architecture, we have an enormous number of examples in which architects or artists or philosophers, for that matter, have conceived of systems that have to organizing knowledge, to organize data in space. And of course, these operations, of course, belong to another kind of period, but nevertheless, I think indicate that the profession is perhaps better equipped than we initially think in order to deal with these sort of problems. For instance, in Giulio Camillo's theater, which is the one on the bottom left, 16th century example of a piece of architecture that should have contained all the knowledge of the time, the issue of memory is addressed as artificial memory. Basically, these are all examples of artificial memories that have been developed. The problem, of course, is a problem that begins with the designers, begins with us, with people that have to engage and make meaningful use of these technologies. And this, I think, is an image that is interesting, not only because it's also my background, but it's basically a graphic reorganization of an unsupervised classifying algorithm that tries to basically redraw clusters of similar data sets out of a very complex data sets that consist of many different layers. So this is the kind of image that architects now and urban designers need to confront themselves with. And of course, the question is one that, in reference to the previous slide, no longer can rely on forms of organization that have rhetorical values, such as ladder, trees, or grids, but requires basically other ways of engaging it. So I think that the proposition here, also in regards to the two introductions that Pablo and Tom gave, is that architects need to basically expand their design process well beyond the design of the physical space, but even of the space of system, in order to include their in the design process images like this one, that is ways in which they can interrogate complex data sets and use architectural knowledge to navigate these spaces. And the second one is, of course, as I was mentioning a second ago, that architecture has a very long and well-established tradition of being able to deal with domains that are that have to do with organization of spaces, but also of data, but also to deal with domains which are initially difficult to catalog. Yeah, after all, the architectural drawing as a notational system emerges at the time where the Gothic building site was deemed to be too complex to be organized by simply word of mouth or interaction between the builders. So the act of drawing itself is already a way in which we are, as architects, we have developed tools to deal with domains that we are not familiar with and that we need to sort of conceptualize. It is for this reason that I think that the cryptography is perhaps a valuable domain to consider for designers. Of course, cryptography is, on the one hand, completely at the center of computation. Computation itself is a cryptographic problem, is constantly a problem of translating set of signs from a language which has, it's a symbolic, but definitely doesn't have any semantic quality, to languages that have semantic quality. But also, cryptography, speaking of the image we saw a moment ago, is basically the art of surveying a territory that makes no sense, that is incomprehensible to the visitor of that territory. And therefore consisting a series of techniques which are playful and yet precise to inject intelligibility within sets of signs that don't have semantic qualities yet. So obviously, again, as I said at the beginning, I'm going very broad and general on these things, but I think it's still interesting to see that, for instance, in Lull or Giordano Bruno work, the cryptographic approaches were used well beyond the idea of concealing, the secrecy of diplomatic messages, and used to actually unlock the secrets of nature, or in the case of Lull, even the secret of the universe. And of course, there's Alberti too in this story, because Alberti is, after all, the inventor of the polyalphabetic system, which is interesting in this conversation because it's the first system of cryptography that requires mathematical knowledge in order to venture into this incomprehensible territory of science. Anyway, I'll keep moving on because, of course, the story, and I repeat again that I'm giving a very broad overview of things, but it's important to point out that at the very beginning of the 20th century, a series of mathematical techniques were developed in order to survey, navigate set of, let's call them meaningless signs. And of course, Markov's work at the very beginning of the 20th century, is central in order to use pure statistical methods to begin to extract some form of knowledge out of basically any set of signs. Yeah? So we are moving into a far greater generalization of principles of cryptography to pretty much any domain of science. And of course, Claude Shannon's work is also part of this lineage, not only because Claude Shannon also worked on cryptography, but also because it's a purely statistical method that he employs in order to begin to inject intelligibility in strings of signs that would be, like as I said, meaningless to begin with. So what are the potential for the this kind of way of thinking about data and technologies of machine learning in architecture? So what is at stake, I think, is the possibility of distributing the way in which we think. So the possibility of thinking together, to think at a very large scales, is one of the possibilities that data and automated process of classification of data can give architects agency on. And I think even at the opposite end of the spectrum, even at the microscopic scale of, let's say, subsidence, right? As this satellite images shows, we also have the possibility to engage elements of urban design which were not fully or at all possible to engage before. So I will just now move perhaps more quickly towards some of the examples developed in RC14. So I'm trying to sort of narrow down, yeah, the topic of the conversation and discuss perhaps more specific uses of machine learning algorithms. So, for instance, as I mentioned, the possibility to work at different scales simultaneously is here illustrated by a research project that was concluded last year, in which students became interested in every time two or more pieces of infrastructure crisscross each other, virtually forming, or actually physically forming, an island in the city, and started to work with automated processes to find out every single instance of this condition in the whole of the UK, and that became somehow the starting point for the project. Or at the same time, the use of data and algorithms to classify and correlate data is also used to understand better how people might navigate urban environments, what kind of direction and surfaces or speeds or they are traveling through urban environments with, and therefore allows us to redraw the city with a very high level of granularity and understand basically how time is spent within the city by pedestrians and even, as I said, what kind of surfaces within the urban environment are perhaps the more noticeable or the more observed. Classifying algorithms also have present us with two kind of spaces. This is why I was mentioning at the beginning that these two spaces need to be seen together between their, let's say, geographical, geolocated distribution of data on the one hand, and the other one, the distribution of the same data set within the space of a classifying algorithm. Now, in this particular case, it's a Disney algorithm, so it's limited to 3 dimensions, and it's an algorithm that is specifically designed for us, for humans, right, to try to make sense of the complex multi-dimensional space of data. But I think in these two kind of mode of organizations of data, which are kind of fragmented, non-continuous, there's something quite interesting for designers to think of organizational models that can connect them. One more interesting, I think, exercise that we run within the research cluster 14 is called rewritings, and it is run very, very early in the year when students perhaps don't even have a project yet, and it's a series of experiments in which students, after having mastered techniques for data gathering and classification of data, experiment very freely, so without any sense of program, site, or even scale, with venturing through the multi-dimensional space of data, and venturing it in a way that is obviously formal, that utilizes architectural forms to develop sensibility, a kind of sensibility for the multi-dimensional space of data. And the process is one of learning, therefore it's also one of play, in which somehow one needs to almost sometimes even intuitively get a sensibility for working with large data sets and with classification algorithms, all of which are unsupervised in this kind of examples. So there are also, of course, conversations about having a syntactical rigor, but having a kind of semantic openness and freedom to reinterpret some of this configuration, working with granularity, and exploring really how to design with the many. This also allows us to rethink the city a little bit. So this is a project that is in progress at the moment, which thinks of what the kind of distributed university could be like, and uses a data set of 55,000 rented rooms in London, and imagines each one of them as a potential room of university students that need to take part to the same university. And therefore, algorithmically, it's possible somehow to recenter the urban network on each of these 55,000 objects, and think about what kind of connections with the city each room can have to become a piece of a larger distributed university. So this issue of distribution, again, it can then be implemented towards, let's say, more directly urban and urgent problems, such as the post-pandemic world. So these are some of the analytics in trying to connect the elements together. Or other projects look at the, let's say, non-human ecologies of the city. This one works with the sound and how it's possible through data analytics coupled with generative algorithms to conceive of public spaces around the issue of sound, of acoustics. So this is a GA algorithms that, based on the trained data sets, begins to articulate surfaces to produce a certain kind of acoustic effects in the city. And finally, this project, which was also reworked and exhibited at the Centre Pompidou last year, actually uses, again, unsupervised neural net that is trained to learn to navigate through London based on data sets that, again, students have collected, and then is connected to a GA, which begins to articulate, let's say, these compositions of objects within the city based on the trained data set, and eventually is used to design all the public spaces in the Ile de la Cité in Paris. That's why it was also reworked for the Pompidou, so that we tested both in London and then in Paris. Again, it uses this kind of highly discretized design language. And eventually proposes a redesign of the Ile de la Cité, well, the public spaces of the Ile de la Cité in Paris. So in general, like I said, in conclusion, really the work always balances between thinking of the space of multi-dimensional data as already an architectural space, a space that can be investigated by using architectural knowledge. I think I can stop here. I may have actually gone over time already, so I appreciate for the patience. And I look forward to continuing the conversation with the other guests. Thank you.
Thank you so much, Roberto, and thank you really all for such amazing presentations to our four panelists. I'm actually very amazed and also encouraged to continue this type of conversations, because I thought that the contrast between the different presentations was truly very interesting. So now we're going to proceed to our moderator. We have two questions by us, each other, actually Tom and I. We're going to ask that addressed to everybody, so feel free to jump in. The first question relates to the difference between, perhaps the difference, or perhaps maybe more weighting towards the second part, which is the difference between non-supervised machine learning and generative adversarial networks. And in particular, one of the questions that I have maybe, and it's very different how the four of you are working through them. So I'm particularly interested in the different opinions. In generative adversarial networks, for instance, we can work articulating different types of computation. To me, that's the most interesting aspect of it, the fact that there is a kind of competition, of course, that's why it's called adversarial, between data flow, right, which activates already issues of data science, right, and perhaps what we can call the classical type of computation, which is symbolic-based computation, which depends on how we decode signs. One of the aspects that Roberto was mentioning through cryptography, which I'm also very interested in and I'm doing research on, which is in the case of generative in GANs, right, is played through TensorFlow or weighting, right, articulating through symbolic computation, different ways of funneling and filtering and mediating different types of information flows, activating different paths in different neural networks. The problem that I have with size transfer, for instance, which I think many people discuss and is being recognized nowadays, is the disjunction when, for instance, in style transfer, we're supposed to look at the work of some previous architect, artist, whatever, and be able to transfer through a certain type of intelligence, certain attributes. And my problem is the politics of how that attribute is being changed relative to how the programmers are understanding what is style relative to language, and relative to language in terms of what Roberto mentioned, right, in terms of signs. And what I find is that the work that has been done in terms of style transfer is highly apolitical. It lacks of political structure because it's basically transferring attributes of visual, if you want, aesthetics, but not the actual politics of that aesthetic related to the structural transformation. For instance, in the work of Picasso, the famous relation between foreground and background, different point of view, that nothing of that remains, right, in the last result. So how do you articulate the difference between style transfer versus perhaps a more structural way of addressing the issue of artificial intelligence related to recognizing of structure, or the difference between style as visual and style as a linguistic based syntactical problem? And this is addressed to anybody, any of you. But to me, it was very interesting how I think it's visible in your work, the difference in a way. Perhaps some of you are more interested in design as a visual sort of approach, and some of you are more interested in syntactical differences through grammar. And I know, Jose, that for instance, you work with shape grammar. You have been doing amazing work through many, many years, also continuing the work of some people at MIT, even looking at the work of Palladio in terms of a very different approach to grammar as in itself. So I don't know if any of you want to address this first question.
Maybe I can jump in to talk a little bit about style and the use of grammars. So there is a fundamental difference between rule-based systems and machine learning. Is in rule-based systems, you can basically explain how you arrive at the solution. You can trace back all the decisions that have been made. In machine learning, you cannot do that. So that's a fundamental difference. I don't mind to use one or the other. I just choose which one to use depending on the problem. But I would like to cite the work of one of my PhD students. She looked at 3 different grammars. The grammar from Palladio that you mentioned, the grammar that I developed for Álvaro Siza, and the grammar of Frank Lloyd Wright Prairie Houses. And she developed a higher level grammar encoding all these 3 grammars. So style, in that case, became the frequency with which you use certain type of rules instead of others. So you could explain difference in style, by explaining which rules you prefer to work with. Obviously, you could also look at style, by understanding the structure of forms or the forms generated by the different grammars. So I prefer, because I think it's easier to talk about, the rules that you use, that you chose to work with. It's just simpler and less subjective. But obviously, style from an aesthetic perspective is also very interesting. And maybe in that case, machine learning would be more appropriate to use to find correlation between, the different stylistic aspects and the rules that were used, to generate them.
I mean, you raise an important issue, which is the difference between, to me, at least the way that I understand it, between data science and simulation, actually, and rule set. In rule set, and perhaps since 2010, that has been the split between something that can be traced back and something that cannot be traced back. And there are advantages and disadvantages, for instance, right? Like the fact that a simulation cannot be traced back, right? Is actually an advantage from kind of a different type of computing reality, because you're in front of kind of emergent systems, and truly certain type of simulation engines cannot be traced back because it's unpredictable, right? And so I think it's a very interesting problem, and I don't know. Perhaps to me the contrast is between Sandra's presentation and Jose's presentation. There is evidently a very different type of position. I don't know, Sandra, you want to say anything in relationship to style?
I think that's a very toxic, almost toxic term in architecture. So some really embrace it, and for some it's really important to have a specific style. Others hate it, and they really don't want to get involved in any stylistic proclamation, or don't want their work, see their work in one stylistic field. But I have to say, in terms of machine learning, we just recently had a lot of discussions with the team from computer science, because for them style, of course, has a completely different meaning, and they need this terminology to distinguish and label specific data sets. So what we had to do was find a way to be less biased and less political about how we approach problems. For example, as we all talk about big data, but at the end of the day, what we can really compute now is not so large a field, where specifically when it's such a complex task like generating an architectural project. So there is really still a lot of big data that needs to be generated first, and that's what we have to do now, because there's no actual 3D database for architectural objects. I mean, there's a huge amount of existing data that we could use, but we have to find a way how can we get agglomerated to make a sort of new ImageNet database, you know, so where we can actually have access to, everyone has access to. And we were starting this actually with RA Lab. Now we have our first very little grant for our first students to start modeling and labeling these data sets. And here we try to be as much without bias as possible, but it's really hard, because how do you access information that we see now that's a Baroque church? How do we access it now? And how do we say what's the equivalent of Baroque in China? Right, so we have to be very careful with labeling of this data. So I mean, we came now to a partial solution for the moment, but I think that's the scientists, they like the more they liked specifically the architectonic formation and geometry aspects more than just purely semantic. So as much as I would like it the other way around, it proved to be that they really need the historical background embedded in the cultural background. So chronological events in the background of cultural events. So.
Tom, you want to go to the next?
I think it's a good segue. I was just waiting for enough silence. I'd like to also really thank all four of you for your presentations, which were varied between real design engagement and theoretical positioning in a history or prehistory. And presentations were insightful. I'm spinning with information here. I think this question of the relation of data and whether that data is two-dimensional and image-based or three-dimensional segues a little bit to a question concerning the training of databases in AI GANs or machine learning style transfer, which generally involves procedures based on the techniques of image recognition, effectively embedding historical archives of images into the computational recognition and learning mechanisms that are triggered. In simpler terms, the sampling of images implants the semantics of history to create a culture of the image. In effect, AI predicts the future from sampling from elements sourced and sampled from the past. And paradoxically, during the last several decades, we've seen at once the pursuit of disciplinary autonomy and historical rupture, and on the other hand, efforts to repair and resume historical continuity. And with respect to the primacy of images as a basis of design procedures in AI, in which ways does AI extend the last 50 years of postmodernity in the ways we use historical media, imagery, references, and data? Also, AI procedures are often constrained to the use of images applied as data sets of pixels in 2 dimensions, in images. Can the panel comment on the methodological transition from 2 dimensions to 3 dimensions, from the image to the model? Sandra, you began to describe this sort of question, which is a huge one between the 2D and the 3D, between the image and the model. Especially at the scale of urbanism, in which the urban plan is often taken as a 2-dimensional image input. I think certainly Roberto and Sandra, you both presented images of master plans or of urbanism as viewed as a plan, and in this sense, the scale of urbanism in some sense is often understood in these sorts of machine learning techniques as an image that is of 2 dimensions. If we can open a conversation about this.
Maybe I can start the conversation, if it's okay. Well, of course, the question is is very relevant and rich. I would say maybe a couple of points are worth pointing out. The first one is that most of the work that is more directly dealing with data and the organization of data is not based on images in the kind of work we develop. And why so? Because in a way, I think it's very interesting for an urbanist, so maybe there's a disciplinary point here, to think of the organization of the city first, before delving into very specific conversations on, let's say, form, style, materiality. So the data sets that we work with tend to be, let's say, not an expression of a particular style. So for instance, could be income distribution, access to public transport, pollution, yeah, and so on and so forth. Now, this in a way is different from images, but it's still very close to the point you were raising, Tom, because even if they are not images, inbuilt biases coming from, of course, data being a representation of our own past, are not necessary. You know, that's the problem is still there, even if they are not images. There could be still biased data sets that photograph the city as it was and take it as the starting point as the city that should be in the future. So I think that that's a problem that is complex, and I don't have an easy solution out of that. So I think that's one part of the question. The second part of the question on the preeminence of plan view, I think that perhaps in some cases there are technical limitations, which I think Sandra extensively explained, that still trap us to the 2D world and make an excursion into the 3D world much more complicated than we would like to. But I think that in general, perhaps there is how the project is represented as a 2D plan view more than how the project was generated in the first place. In the project on data is basically an infrastructural project, is a project of organization of the city and its flows.
Yeah, can I jump in? You know, it's an interesting question, because there were two parts, I think, Tom, in kind of the idea of, if we're thinking back 20 years or more ago, like the idea of something being digitized was a kind of an equivalence, like one could work without scale, one could work between different media. There is so much to, to think about, whether it's vector or pixel, right? So you end up with these kind of artifacts that are deeply embedded, as we continue to keep moving and changing. And I don't want to just talk about the past, but, Sandra, the reaction of thinking about style, right? So if you don't mind, when I was working in like late 99, I remember visiting Carl Chu in his studio at the time in Los Angeles. And he was working with L systems, so it was very rudimentary. And at a certain point, he pulled out a set of drawings that were kind of what we know, like the green with this kind of, you know, sine waves. And I said, Carl, so what just happened between the L system, which is organizational, it's computational, it's kind of without material, and what is that? What's that translation, right? What is that? And I said, these drawings are beautiful. And he was working, you know, he was printing, I think, with pigment ink and so forth. So that these artifacts were beautiful. And it was a similar reaction. And I'm not saying that we haven't moved ahead, but I think that there are fundamental kind of questions about representation, about authorship. It also reminds me, you know, I've spent kind of since maybe 2004 kind of working on more of the Italian stuff as sort of proto. So sometimes I'm sorry if I'm not fully up to date, but I think some of the fundamental questions are there. How one chooses, is one designing that kind of that interface, that geometric interface in that case, and then this whole other set of, you know, decisions. Are we in RGB or CMYK length? You know, how we even contemplate color, right? How do we? So I think those are like stylistic issues, issues of beauty, issues of authorship, right? Like how does one select, right? So it was interesting in the CISA example, Jose speaking about like at a certain point, you know, the architect is like, I don't know if I generated that, like that we end up with these kind of combinatorial, or we've seen that also in Roberto's historic work and thinking through the generation. So I just, you know, the idea that even, even in older practices, like how we draw plans and we bring those plans in relationship to each other, right? Are they scaled? Is there kind of a continuity of how poche is being shown? Like, I think, anyway, so I think that those are things that I write about or I think about that are kind of profoundly, as we keep moving through with, you know, new discoveries and new systems. I think back to Roberto, it's like, you know, an idea that there's data. I also teach I teach urbanism at Yale. I teach history theory at Pratt. And, you know, we are working with GIS systems and trying to understand data and kind of understand what those underlying aspects are in urban conditions, right? But then it's always that jump of how one makes that next translation. And I do think that fundamentally at a certain point we choose, you know, so I'm just wondering, like, you know, where is their agency? And I suppose I'm drawn to the work in the 60s where, you know, wonky or not, you know, looking at Yona Friedman's work or looking, there's an idea of participation or kind of understanding of who the constituents are, who the citizens are, so that there's some level of us as like Antonio Gramsci would talk about, like, you know, the idea of the public intellectual. Do we own that part of our own training, and how do we kind of understand that we have those skills and we can mediate? So I just, you know, and then it's kind of animal, you know, plant, mineral, you know, this kind of greater context that we've kind of been in the, you know, past 10, 15 years. So great questions, and really thought-provoking to speak with everyone today.
Thank you, Sandra. And this gives me room for the third question, which is a little bit more problematic, and perhaps Tom and I will have been having a little bit of a discussion on it, which is the issue of authorship. And you know, it's a particular problem that I've been obsessed with, particularly at the Cooper Union since Acadia 2010, in which the question is about the problem of power and control. And that also transfers to the issue of which data do we use and who is the author of that data. So for instance, we tend to depend, I think, too much on government data. And I wrote a recent article on actually problematizing that notion. And I like extending or expanding authorship to even address survey systems, because I think that if we use governmental data, we are trapped by the politics of control of the government. And I'm not a libertarian, right, in economic terms. I think that I'm a Marxist, right? But the problem is true, which is how data is actually constructed through zip codes, for instance, right? It's extremely problematic. And Roberto, you mentioned the geopolitics, right? And to me, that's essential in urbanism. And so, for instance, from survey to data that we use, how that data is being collected, what are the biases of that data? data is totally biased. The way it is being measured, validated, and controlled by systems of representation. When I come into the United States 20 years ago, I was shocked by the first card that you get in the airplane asking, how do you identify yourself? Because I said, this is crazy. I mean, you're trying to tell me how am I supposed to accommodate to your standards of structuring, how you're structuring reality. And that creates, in fact, types of citizens, right? So to me, the relationship between AI systems, software, computational systems, and reality, I tend to think of them relative to McLuhan's media determinism, right? Like, what is the media, how you're relegating yourself even. We are relegating ourselves to Facebook algorithms, to our cell phones algorithms. We have how many millions of algorithms now running our lives, right? And the self-awareness of that is problematic because we know now it's public, right? That Facebook knows more about us than we know about ourselves, right? And that includes the design agency, because when you're using, and that's a problem that even with cellular automation came up in the game of life, right? What are the opportunities for self-replication? What are the conditions in which you are running your agency? And what are the possibilities of that agency to create emergence or not, right? So in that sense, to me, with AI, that becomes even more problematic because the authorship is not so easy. I mean, and I know, Jose, I kind of agree with you. It doesn't matter to a certain point, but I think it's extremely problematic who develops the data, who controls the data, what are the powers and control authorities, and what do we do as architects in relationship to that? Because if we are just exploring the possibilities within a given technology, I think we are trapped and doomed by Negroponte's anticipation of that problem, which is we're going to disappear, right? And I think that the role of engaging ourselves into the development of new technologies is a game of life. It's a survival. It's kind of like you cannot choose, because if you think that you're choosing, you're already run over by a system, right? So in that sense, to me, the issue of authorship has to do with how much are you aware of your own matrix, your own reality, and how much you think are the possibilities of distorting that matrix or addressing the politics of control of that matrix, and how you're thinking in terms of emerging technologies as disruptive technologies, and how you think you can intervene in that sense. And I think that the question of authorship has been run over in a kind of positivistic way by shared authorship. And I think that the only chance today we have is with blockchain, with, for instance, blockchain, social media, blockchain, mediums of sharing control. And in that sense, I agree with Tom in terms of sharing authorship, but the problem is who controls the platform, who controls the medium. And we have been seeing that the ownership and the authorial of the platform is dominant over the content developed in that platform. And that raises the necessity for our architects and urbanists to develop their own systems. And by the way, that's the idea that we're developing for a new upcoming MS program in architecture computational technologies, in which we're going to aim at actually advancing architecture through developing our own systems. But it's maybe a comment, and perhaps to put some of the issues at stake and how you think about the politics of design relative to the ethics and who controls the data and who controls the platforms.
Well, it's wonderful, Pablo. You have a wonderful parabola that also already answers the questions that you pose. So I think you just answered the question of what we should do and what we should establish. And I think we have two ways: train ourselves, and then in teaching, how do we train our students? You know, what knowledge should our students have to be able to participate in this game? It's obvious that we have to partake. We cannot just avoid it and say I don't like it, so I don't use it. So because we're all using it, and the problem is we don't have a choice anymore. The choices to use these tools has long gone over. Jose, you wanted to say something?
Yeah, I was going to say, I mean, I would distinguish between the author of the design or the supposed author of the design, and who controls the data, because these are two different things. When I said I don't care about the authorship, I was referring to the author of the design, but obviously I care a lot about who controls the data, because that's going to completely constrain what I'm going to do. So I will distinguish between the two. And I think it's very important for us as designers to have some access, direct access to data acquisition, not depend on third-party data, to base our designs. I think that's very important.
Yeah, maybe I can.
Okay, sorry.
No,
are
please,
we going
Sandra.
over time or? I would say both are important. For me, design is just as much important as I was living now for a year in the suburbs, and I tell you, this is not a good place to be in a year in. So it's my first time back in a city and I'm alive. So obviously it's a necessity. It's not just a nice thing to have. It's really a necessity to have a cultural space. I think I'm very happy to have grown up in a time before social media. I think I don't envy the young generation, how they're being trained, how they have no space to develop, and I think that's something we have to provide for them. That should be our legacy within all these Google but Pablo, I'm not so much concerned about countries anymore. I'm much more concerned about concerns and companies like Google, Facebook.
Of course, yes, of course.
Amazon.
Of course.
So they have to take a responsibility. They have to start to take responsibilities.
Well, in a way, there is no, I mean, obviously corporations are more powerful than countries today, right? So that's what you're saying. Yeah, I agree. Roberto, you want to say something?
Yes, no, of course, again, super, super interesting and tough question. But first of all, I want to say that I agree with Sandra that digital literacy needs to become part of the equation. Yeah, whatever, we can discuss exactly what goes under the label of digital literacy, but that's why I was trying to say that we need to think architecturally about data. Yeah, we just have to, the same way we think architecturally about light or color, we have to develop a sensibility for these kind of spaces as well. Then on the authorship, I'm not too worried yet. Maybe I am naive, but I'm not too worried because, I mean, I wish we could say that the author is disappearing, because it takes a phenomenal number of hours to get these things going and produce anything even remotely interesting. So at the moment, I think that it's perhaps, it's perhaps sometimes a media twist to make, chair designed by robot, city designed by robot idea. Not so much. It's still very much a process in which at all levels humans need to intervene constantly. And maybe the final point is, I don't know if this is shooting way too high, but in a way, I'm not too concerned about these problems also because of Gödel, no? You can't have it all. There's nothing that it will be a complete mathematical system that has no gaps, no contradictions. It's just not going to happen. And maybe we should accept that our intelligence in this system will always be needed, and therefore learn how to talk to these systems more fluently.
Perhaps building on this question about authorial control, maybe authorship and control are two very different issues when it comes to design, or really just our position within a larger sort of matrix of communication and information. The notion of authorial control does very much go back to the concept that that the individual is in control of everything in terms of design. And these distributed systems that Roberto, you're talking about data are firstly compiled through a manifold of interactions that are multiplicitous and not about any individual. So I think that the whole notion of authorial control is to be questioned.
Mhm.
And maybe this leads to other issues about, you know, design when undertaken with traditional, you know, media or more conventional media than what we're talking about today. It was formerly understood as a form of predictive control. We perform very specific operations to achieve outcomes which we expect. And this form of authorial control has eroded very much long before what we can say is a digital era for architecture and urbanism. And AI in this context presents an unprecedented opportunity and challenge, which holds the promise for the designer to further relinquish control. And maybe some of the following questions, we're running on in time, point towards the status of surprise and serendipity, accidents and mistakes in the pursuit, for lack of better terms, novelty. And AI can be applied towards the performance of optimization, of course, optimization of known solutions, as well as for generating the unfathomable, what we have not yet thought possible. So how do we train, to formulate this as a question, how do you train data sets to exceed the recognition of familiar patterns to come up with novel solutions? How can we train an algorithm to recognize the opportunities of errors or outcomes which surpass the bounds of expectations, conventions, and propriety? In doing so, are we allowing data sets to take control?
Maybe I can start answering this because this is a way of perception. So who is actually perceiving this then, you know, the intelligence of AI systems? I mean, if they were intelligent, let's say they would develop their own intelligence, probably we could not see them. They would probably develop their own creative system, you know. So how far do we train them to play Go? Do we also train them to go beyond Go and then develop their own game? Is it a game that we would understand? You know, so that's a question that I think is hard to answer. But at the moment, I would say that so far away from where we are at this stage, at this point, I think it's really it's really more a question about what we think of creativity. And I think we at the moment we're using AI to think about how creative is the creative industry in the first place. Is it creative, or is it just pulling out things from the modernist box or replacing these things? So is it are we truly genuinely inventive? You know, when I'm a very happy person if I have one good idea in a year, you know, so it's, and then can write up a paper probably about it or have a beautiful project connected to it, you know. So it's to be really genuinely creative, there are a few moments in life when I think you feel it when you have achieved this.
But you know, to me,
and the computer does not.
In terms of
not yet.
you know, in terms of creativity and limits, Ronald Barthes, when he declared the death of the author, mentioned the limits in language, right, as the ultimate barrier in creativity. And that's what I'm referring to when I refer to authorship, and usually it's misunderstood because I'm not claiming, you know, the sole author, but at the same time, we have to recognize the philosophy and epistemology of the time that we live in that activates an ideology that goes beyond our own intentions. So for instance, even though we are claiming that we are sharing authorship, you have a new structuralism growing, right? Mainly addressed by big tech, right? Big technology. And you have a new epistemology, right? There's a new means of accessing knowledge. And I think that the type of top-down reality that we live in is more similar to a new renaissance. That's why I agree with people that they claim that AI is bringing a new renaissance in the good and the bad, The bad of the Renaissance was the fact that perspective, for instance, homogenized space, right? It was a very interesting system of representation, was novel, but replaced all reality with one system. And I think with the AI, we run the risk of activating a new kind of structuralism, a new type of tabula rasa. And if we are not culturally aware of the biases of that, we're going to repeat the pendulum. You know, obviously, history is a pendulum back and forth, right? And we need to be aware of how we're going to anticipate the new type of structuralism that we're working with, and how we're going to be able to displace that if we are able to. And I think today big tech is winning over our intentions of, like, for instance, we are gladly sharing comments in Facebook, but you know, the platform is always winning, right? It can regulate what we see and what are we looking at in relationship to a commercial ambition, right? So I think that is very problematic. But in any case, there are some questions from the audience that perhaps, Tom, we want to address. And there, all of a sudden, there are many. I saw there was one, and now all of a sudden, many are. So Andre was the first one, if I am not mistaken, says, can you please comment about tools and data as a knowledge commons, right? That's a very interesting problem in relation to what we're discussing, and social accountability. I don't know if anybody wants to jump in. I think it's a very interesting problem in relationship to what we're talking about.
So regarding the issue of social accountability, it's definitely, you know, very important. And it goes back to this idea of who controls the data and how we use the data. So if we choose to use certain data, we should be held responsible as well, because we chose to use that data. So we need to be socially accountable for our choice of working with that data on which to base our design. So it's not just, you know, who produced the data, it's also, you know, our own choice of using it.
Matthias is raising some questions in relationship to how we are understanding authorship. And I think that the issue of authorship, you have to be aware of the history of the term and how it came to be. And he says that Matthias agrees with Roland Barthes' question, right? And I wanted to raise actually what Roberto, because I talk also on the relation between cryptology and cryptography and computation. Because to me, the moment I realized how Barthes, back in the year 2000, I started addressing computation from digital science, and I'm trying to create digital science. It's very difficult, but that's what we're trying to do with the students. And it's a question of cryptography, how you encode information differently from the available systems and how you're able to expand. And I'm very happy, actually, I did not know that you are interested in that work. I don't know if you want to expand on that, because it's very different from what Mario Carpo actually says. Mario Carpo is more addressing the problem of authorship, perhaps in the terms of what Tom is saying, from Gutenberg's reproduction problem of the press and so on, versus I think, Roberto, you brought up, and I'm very happy that you brought up cryptography. I think to me the limits today have to do with cybersecurity and blockchain, and how we are able to articulate a different type of reality by actually going against the media authority. And I think that that's what Matthias is actually saying. Also, he refers to the role of private companies as opposed to, I agree, as opposed to countries. Countries, of course, are irrelevant because we are in a plutocracy, right? So yes, I agree with that. I don't know if you want to comment, Robert, on that, or what Matthias is saying.
Yes, thanks. Yes, I've been working on cryptography for a bit, and I find it interesting for a number of reasons. First of all, when we deal with computation, I think we always deal with the merging of two domains, right? The domain, a domain that historically sits within the humanities, that is, let's call it logic, and the domain that sits within the sciences, which is number. And therefore, first of all, in cryptography, we find an interesting merging of the two things. And this is one element. The second element that is super interesting, I think, is, of course, how central it is to computation. Cryptography has always been one of the tenets of computation. And finally, cryptographic methods, and this is something that I think that keeps coming up, I think, in the discussion. Cryptographic methods move a little bit away from this idea of efficiency, of being efficient all the time. And if you look at the history of the discipline, you see how much more playful certain methods of translating data into different kind of strings of signs have been explored. So I showed 3 examples, but in the first one, in Ramon Llull, it's a cryptographic game that basically explains the nature explains basically a metaphysical system, and as such, in fact, I mean, shows even, let's say, the superiority of the Christian religion over every other religion, and this costed quite a lot to the poor Ramon Llull at some point in his life. But I think that's the really interesting part. And it's the same, I think, for the Albertian system of cryptography, that eventually it becomes a system to translate sign. And I think it's still relevant now because we still need to find a system to communicate with these objects, which are alien, let's say, to the type of intelligence we have been developing. So sorry, I'm a bit, maybe I try to cover broad strokes, many areas, rather than go into detailed answers, but I can come back on things that, may be in need to be more specifically described.
Maybe we have time for one more question in the chat.
Vanessa is asking.
Vanessa Viola. When considering authorship, it is important to remember that it is both constructed and contextual. Authority to who? Data is open, but for who? Exposure to this critical lens can lead students to selecting data and information sources, acknowledging the attribution and authorship, and then contextualizing their new knowledge and proposed design solutions. I think this certainly relates to a conversation earlier about the lack of neutrality of data. If anybody would want to comment maybe on the inherent biases and discrimination in the formation and use of data and its application.
Yeah, maybe one thing that I can relate to this question, related to the work we develop, is that there is a very long period in which students test different data sets. So there is it is not that different from the way in which students, let's say, try the layout of a flat, try different options for a layout of a flat. But in this case, they operate with data sets of different kinds and keep swapping them. There are many other operations we don't talk about, such as how do you make a city machine readable? No, there's a whole problems of what kind of geometrical structures you use to translate numbers into geolocated. So all these exercises are constantly tested. And the point I want to make is this: at no point can you do it without a direction, I think. And this is also similar to the exercises of the 60s. You have to have a certain direction. It won't, then as Jose mentioned, that allows you for a certain degree of accountability between what you want to use and what you don't want to use. The other thing is that once you layer different urban phenomena, these may be measured in scales which are completely different with one another. So there's another kind of subjective layer in which these values need to be massaged in order to have a weight which is defensible, let's say, from the point of view of the person that executes these processes. So the problem is constantly, and that's why I think you need to have a certain direction, which I think also may help you addressing questions of authorships and all the other points that these questions was bringing up.
Yeah, thank you, Roberto. There is another question in the chat, but what do we do, Tom? Do you want to wrap up, or?
I haven't seen the question. You want
no, I mean, it's an interesting point. Milagros Barkis is asking, saying, you know, congratulations about the discussion, but it's addressing the core values of our society radically changing. So I wonder how we should address the conflict of using historical data sets as an input for contemporary design projects that deal with a very different type of reality, which goes back, Tom, to what you were addressing before. You were addressing the issue of addressing reality through a historical data set in relationship to prediction mechanisms, right? And that's, in a way, I think that's one of the issues that here has to be clarified, right? In terms of reversibility. Simulation, of course, is not reversible, right? And when you're using data sets, the problem is the curve fitting or the surface fitting or the fitting to a certain mathematical parameter that addresses an issue of statistics relative to anticipating the future, right? And that's the value of statistics relative to running or training a set. So I guess that Tom, you were touching upon these issues before about the back and forth between historical facts and which is the issue of statistics, right? Like we are now with data science embedded within the epistemology of statistics when we're talking about machine learning, for instance.
So in effect, almost any sort of predictive system is always based on a historical set of facts and data that even if it's real time and present, becomes part of what was collected historically. And I think this problem is in some ways not escapable, and AI is in no way sort of different in this sense from a history of statistics and mathematics and such that is always based and rooted in a kind of history, and that situates our discipline in effect, which is a discipline that's deeply rooted in a history, and its history is immensely important to be able to chart futures which are sort of unknowable. So in some ways, I don't think the use of AI in design is in any sense all that different in terms of our historical positioning about what our discipline is in effect one which is concerned deeply about the future. Design is as much as a reaction to the present, and even more so a prediction of a future which hasn't yet happened.
The only problem of that is what Milagros is pointing out, which I think is interesting, is the time frame, how far you go look back. But what happens when now that we are being simulated, right, literally, in the sense that the operating systems are tracking what we are doing real time, and that is feedbacking real time onto us, right? Or for instance, in Facebook, that the history is like shortened to immediate time by collecting real time what you do and retrofitting that in relationship to optimizing your behavior to consume more advertisement, right? Mm-hmm. So I think that in that sense, simulation and data science is taking over perhaps that notion of history, shortening it to a real-time feedback. That's why operating systems are updating themselves all the time right now. But I don't know if anybody wants to have some final comments, and perhaps we should wrap up because already 2:40. We are. I think it was a terrific conversation, but maybe we are stretching a little bit the time now.
I
Pablo
agree
and Tom,
also.
just to thank you for this wonderful discussion. Very interesting. I think we should, in the near future, we should have more of these discussions because it's coming. It's not going anywhere, and you have to learn how to deal with it.
Yeah.
Thank you also for our co-speakers. I enjoyed very much listening to your presentations. Thank you.
I just want to follow up on Jose's comment. Thank you so much for the invitation. It's really a great pleasure for me to get into conversation with these great panelists. And thank you so much for inviting me. And thank you for all the people who spent 2 hours and more of their life to listen to what we had to say and show and present. Thank you very much.
Yeah, likewise. Likewise, I have to say it was really a great event, not only for the range and quality of the other speakers, but also I thought you set up a very kind of difficult in a way, but super interesting series of questions that we all, I think, walk away with and keep thinking about it.
Well, I'd like to thank all of you as presenters and speakers for putting together really inspiring and insightful presentations. Thank you to Sandra, Jose, Roberto, and Alicia. Thank you, to Pablo. And I guess on behalf of our Dean and Chair, thank you all for joining today. Pablo, if you want to.
Yeah, thank you. Yeah, just thanks everybody. I thought it was a terrific event, and as people say, that the difficult questions that we keep addressing, and hopefully we are going to have you back soon. We're having a second version of this event in August 28, and I think it's promising. And I thank my colleague Tom for taking the challenge and elevating the level of the discussions as always. And I thought that the conversation was very instrumental and that there was a lot of feedback between the presentations and a lot of contrast, which is what we're looking for. So thank you so much. And thank you also on behalf of Maria Perbellini, who's also the creative director of our participation at the virtual Italian Pavilion, for her leadership. And thank you for Giovanni also for enabling us with this event. So I guess we see you back in our next event, July 6th, but also in the continuation of the conversation in August 28. Thank you.
Thank you.